Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on September 26, 2025, about 3 days ago. It introduces a variational reasoning framework that treats thinking traces as latent variables and optimizes them with variational inference, yielding stable training objectives that improve reasoning. The paper is titled Variational Reasoning for Language Models, and the implications for model training are quite significant. In short, the method adds a multi-trace evidence, lower bound, trains the variational posterior with a forward KL, explains rejection sampling, fine-tuning, and binary reward reinforcement learning, including JORPO as local forward KL objectives with an easy question bias, and reports consistent gains on QN 2.5 and QN 3. Also, the authors shared an official GitHub repo. You'll find code initialized from Llama Factory and SkyThought, clear environment setup, data processing, training pipelines, and an evaluation suite. It lists released models and datasets, plus step-by-step scripts for sampling, likelihood estimation, dataset building, and training the final reasoning models with multi-GPU guidance. Moving to the results, Table 2 compares 8 billion parameter models trained on bespoke Stratos 17K. The two variational reasoning variants lead across tasks, with the accuracy-based version posting the highest math average at about 63. On code and knowledge evaluations, both variants also top the chart, reaching roughly 55 on the second average. These gains matter because they outperform the base and bespoke Stratos under the same training setup, which suggests stable and transferable improvements. Alright, Figure 1 shows that training becomes more stable and efficient because loss drops faster and gradient spikes appear less frequently with variational reasoning. The left panels track the 4 billion models, and the curves sit lower with fewer jagged jumps. The right panels repeat the pattern for the 8 billion models, which continue to show smoother gradients. This stability matters, since steadier gradients usually translate into more reliable improvements across tasks. Figure 2 shows how gains scale with more samples. Pass at K means the model succeeds if any of K tries produce a correct answer, which favors methods that generate diverse, high-quality traces. The advantage grows on the live code bench hard panels because complex tasks benefit from stronger reasoning. Gaps shrink on the live code bench easy and GPQA diamond panels, since these tests saturate quickly as K increases. So Figure 3 shows the effect of sampling more thinking traces on final accuracy. A thinking trace means a step-by-step reasoning path that the model writes before answering, which helps the model explore alternatives. Accuracy rises steadily as K grows because the multi-trace objective picks better traces and weights them adaptively. The uplift is clearest on AMC 23 and live code bench medium, while gains remain consistent on AIME 24 and AIME 25. Wrapping up, 2 takeaways stand out. Treating thinking traces as latent variables with a multi-trace evidence lower bound and a forward KL gives stable, scalable training, and the variational view unifies reinforcement learning style methods while exposing an easy question bias. The implication is clearer objectives that lift reasoning across harder tasks. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.